Good evening, everyone. Welcome to day 6 of our 15 days free training program on Python for AI. Before we move on to day 6, let's quickly recap what we learned till now. So, we have started learning data types in Python. So, there are six main types in Python that are fundamental category data types. So, in that, we have int, float, boolean, and complex. Int data type stores whole numbers and it supports four number systems, that is decimal, binary, octal, hexadecimal. And then moving on to float. Float stores decimal numbers and floating point values, and it is immutable. And then we have boolean, which stores true or false values. So here true means 1 and false is 0. Internally it considered as 1 and 0. And this is used in conditions. And when it comes to complex, it consists of real and imaginary part. So for example, the format is written as a plus b j. Here a is your real part and b is your imaginary part and j is under root of -1. So this is used in advanced mathematical computations. And then we've also learned about sequence category data types. So in sequence category data types, we have string, bytes, byte array, and range. So sequence category data types are used to store ordered collection of values or sequence of values or characters. So these sequence category data types will maintain the insertion order and they also support indexing and slicing. And these are iterable. So yesterday we've started list category data types. In list category data types, we have list and tuple. And we've learned about list mainly yesterday. And then, so list category or the data types is used to store multiple values. We've also learned the predefined functions which we can use in the list. So it stores multiple values that is of same data type or different data type or both data types. And also it allows us to store unique and duplicates also. So list data type will allow unique values and duplicate values. It also allows same data type elements, different data type elements, or both the types. And it also maintains the insertion order. So in which order we'll insert the elements, in that order itself, it will display. And it also supports indexing and slicing. So this is what we've learned yesterday, and we also learned about the predefined functions, which we can use with lists. So in that predefined functions for adding elements, so to add elements into your list object, we can use append function. So this function is used to add single element. And we can also use extend function. So you can add one list. So list 2 you can add to list 1. And you can also have a function called as insert. So this what it does is it will insert your element at the specific position you want, like the index. So insert is used to insert element in the list at a specific index. And then we also have functions which are used to remove the elements. In your list, if you want to remove elements, you can use functions like pop. or inside of pop you can give the specific index and you can remove the element at this position of index. And then you can also have a function called as remove. So if you know the specific element you want to remove, you can use this function. And also, if you want to know the index of specific element in your list, you can use index function. And if you want to know the number of occurrences of some element in your list, you can use count function. So count of, you can give the element here and it will give you the value. If it appears 4 times, it will give the value 4. And also for sorting into ascending order, you can use the sort function. If you want to sort in descending order, you should use a parameter reverse inside of this sort function. So we have a parameter called reverse. You can give reverse equals to true. So just if you do the sorting, it will give the ascending order. And if you want to sort elements into descending order, you can give sort function of reverse equals to true. And also there's one more function which is called as reverse. So what reverse function does is, it will reverse all your elements in a list. So these are some of the functions we have learned yesterday. So today we are going to continue with the next topics in list, that is firstly inner or nested lists. So firstly, what does a list look like? It will look like some variable name equals to elements. That elements can be int or string or float or anything, boolean, complex. So let's say we have a string that is called as marks. So list is used to store marks of, let's say, 3 students. So marks of first student is, let's say, 85, 90, 78. So this is student 1 marks and this is student 2's mark and this is student 3 marks. So that's easy, right? Just a list. Now let me ask you something. So each student won't just have one subject, right? He'll have more subjects like 7, 6. Let's say he has a, so student 1 has 3 subjects, let's say. So how can I store 3 subjects at a time for the student 1 in this list? I cannot store it in one flat list, right? So if I just store 20, 85, 30, 90, 78. So which marks belongs to which student, I wouldn't know. If I just give in a single list, I wouldn't know that. So we will lose the grouping here. So that is where nested lists will come into picture. So what is the nested list? Nested list or inner list is nothing but a list inside of another list. So nested list is nothing but a list inside of another list. So what it means is, one of the elements of a list is itself another list. So for example, I have a list. So I have a list inside of another list means, so this is a list, the main list, and inside of that I have one more list and one more list. So these are called as inner lists. So the element of a list itself is a list. So I have a list inside of the bigger list, or 2 lists I have here. So these are called as inner lists. So let's take some example first. Let's say we have a list. So we have some matrix. So 1, 2. So this is one list inside of the bigger list. And we have one more list 3, 4 and one more list 5, 6. Okay. So here the elements of a list are itself lists. So these are the inner lists here. So inner list will support the indexing and slicing also here. So basically, the first bracket here, if I want to access this elements, so how I can access is, we know the indexing, right? So this is one element in this list. So this is one element. So the index will be 0 for this first element, and this is the second element. And that is the index of 1. After 0, it is 1. And then we have one more element that is with index 2. So I want to access these elements, let's say. So what will I do? I'll be giving matrix, which is the variable name. And inside of that, I'll be giving a square brackets and I'll give 0. So what does this give me? So this is the first element with the index 0, second element with index 1, and third element with index 2. So this will give me the output 1, comma 2. Okay. So it will give me the element here. So if I want to access elements inside of this list, what should I do is I should give first the element, the variable name, and then I want to access elements inside of the first element. So that 1, comma 2 list, right? So first I should give you the outer index. So this 0, 1, 2 are outer indexes here. And I want to access, let's say, I want to access 1 inside of this list. So I want to access 1. So what should I give is, I should give one more index, that is the inner index. So here, inside of this list, we should again be giving indexes. So here, the first element is 0 index and second element is 1. So I should give 0 and 0. So first, the first bracket will select the element inside of the main list. That is, it will select the inner list first. And this second bracket will select which element I want to access in that list. So which element inside the inner list. So how we can access elements inside of inner list is, first we need to select which element or the inner list I want to access. So this is the list with index 0 and then 1 and then 2. So inside of the first inner list, I want to access 1. So then I should give the index of the element which I want to access. So first, the first brackets and then the indexes, selecting the element or the inner list inside of the bigger list. So it will select this. So matrix of 0 will give you 1, comma 2. Inside of this, I want 1, right? So I'll give one more index. So the second brackets will give me to access which element inside of that list I want to access. So this will give me the output 1. So that is how you can access elements inside of list. So whenever your problem involves rows and columns, so when you can access inner lists is when your problem involves rows and columns or grouped data or else multi-dimensional structures like multi-dimensional data. More than 1 to 2 dimensions, we should use these lists. So in these cases, we can use inner or the nested lists. And also, the key features of inner or nested list is it will support multi-dimensional data. So dimensions means, you know, right? 1D, 2D, 3D. So when there are more than 1 or 2 dimensions, you can use inner lists or nested list. And this also maintains the insertion order. That is, in which order we will insert the elements into list. In that order itself, it will be displayed in the output. If I give in this order the insertion, in the same order my elements will be displayed. and it is also mutable. So mutable means you can modify the inner elements. So inside of list, these elements you can modify. And inner lists or nested lists are used to represent matrices. So you have matrices like in maths you'll be learning. Like this is a, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 by 3 matrix. So these matrices you can represent with inner lists. And also you can use inner lists if you want to represent tables or grids, etc. So how can I modify elements in my inner list? So here if you see, we can access elements using this, right? So matrix first, the first brackets will give you the element you want to access here. So here we have 0, 1, 2. So first bracket will tell me which element I want to access or the which inner list I want to access. So 1 means, so it will access this. So this list will be accessed, and inside of that I'll be giving one more brackets here. So we have 0. So 0 means inside of this, that is 3 comma 4, the indexes are 0 and 1, right? So first element index is 0, second element index is 1. So I want to access 0th element. So 0 means here 3 is the element. So what can I do is I can equate this. So using assignment operator, I can just give you 10. So what happens is in place of this element, 10 will be assigned. That is, the matrix will be, or the list will be, the first list 1 comma 2, and in place of 3, 10 is given. So 10 comma 4 and then 5 comma 6. So in this way I can modify my inner list. So common use cases are, you can use it in 2D arrays, that is the matrices. So in this way, and you can also use it in image pixel data. So when you have image, so that is used or saved in pixels, right? So you can use inner lists in that use case, and also in game boards you can use it, and also to store grouped data you can use inner list. So let's move on to coding now. So we have an inner list here. Student info is my inner list, or stu info. So in that list I have many values. So list will allow us to insert any type of values, right? Like int, we have string, we have one more list, we have and another list inside of a list, and also one more string. So that is how my data is here. So first let's run this, and the elements inside of stu info is my list 10 comma rs comma 30, 19, 15 list, and 76, 56, 67 list, and one more string OUCET. Okay, so I can access elements. So indexing, I can access elements by, so the first list. So the first element here, the indexes are 0, 1, 2, 3, and 4. Because this is considered as one element, and individual elements, right? So the first element index is 0, and then we have rs 1, and this list index is 2, and this is a single element, first index is 3 and then 4. So if I give stu info of 0, first it will select which element we are accessing. Only one index we are accessing, right? So if I print that, I'll get 10. As it is the element at the position 0, I'll get 10. So if I access stu info of 1, so I'll get the string which is rs. So that is printed. So if I access stu info of index 2, so this is the whole element we have at the index position 2. So that is why this whole list is printed. And then if I try to print stu_info of 3, this whole list will be printed. So this is the element at the position 3. And at the position 4, we have one more string, that is OUCET. And as you know, there in list, we can also have negative indexing. That is, from right to left, we can give indexes from -1, -2, -3, -4, and -5. So here we have stu_info of -2. So -2 means which is the element? So this is the element. So this inner list is the element at the position -2. So when I try to print that, I'll be getting the value of 76, 56, 67 inside of that list. So if I try to print -3, so what is present at -3? Here, 13, 19, 15. This list is present at the -3 position. So when you print that, you will get the element at that position, which is the inner list. So this is how we can perform indexing in inner or nested list. And then moving on, we can also perform slicing. So let's have the indexes again. 0, 1, 2, 3, 4. So we have 5 elements indexing from 0 to 4. So here we have beginning in, so inside of slicing we have this format. Okay, so the beginning index is 0, is 2, ending index is 3. So when we have a slicing in this way, what happens is it will produce elements from the beginning index 0 to ending index -1. So 0 to 3 minus 1. That is 0 to 2 only. So 0 to 2 means what are the indexes? 0, 1 and 2. So it will print all these elements. So from 0, it will move till 2. So these elements will be printed. The end index will be excluded. So if I try to print that, I'll be getting the list of 10, RS, the list of 13, 19 and 15. So these are the elements inside of this sliced part. Okay. And then moving on. So I want to access elements inside of inner lists now. So this element is 0, 1, 2, 3, 4, right? So for this element, this whole element, these are the indexes. So the first index will select the inner list or the element I want to access first. Let's think of element, just element now. So 3. So what is 3? This is the 3 index element. That is 76, 56 and 67. And then I have one more index side of it. So this second brackets will give the index of element inside of that list. So what can I do here? 0, 1, 2. Let's first take the element which we can access. So firstly, we have the element 3, that is this list 76, 56 and 67. So we wrote that, right? And then the second brackets will tell us which element index we are giving. So which we want to access. The element index which we want to access inside of that inner list. So 2 means 67, right? So when we give the variable here stu_info and 3 means first it will select this list and then inside of that I gave 2. So this will select 0, 1, 2, that is 67, and that 67 will be printed when we try to print this. So as you can see here, stu_info of 3 is to 2 is 67. So in that way you can access elements inside of the inner lists. And also we can also perform slicing. So as you can see here, first let's put the indexes of the elements in the outer list. So 0, 1, 2, 3, 4. So first we have 2 here. So 2 means the element is this list. So 13, 19, 15. Okay. First this will be selected. The element inside of the bigger list. And inside of that, what I'm doing the slicing of 0 is to 2. First, let's write the indexes of these, that is 0, 1, 2. Okay, so 0 is the beginning index here, and then 2 is the ending index here. So what elements will be produced from this? 0 to 2 minus 1. That is the ending index minus 1 elements. So 0 to 1 only. That is 0 comma 1 elements will be printed. So 0 element is 13 and then 1 is 19. So it will print the elements 13 comma 19. So we can also perform slicing on the inner lists. So if I try to print that, so I got 13 comma 19. So in that way you can perform slicing on inner lists in a bigger list. So I can also use the negative indexes to access my elements. So if you see here, we have negative indexes, right? So let me write the negative indexing. Will start from right to left. So from minus 1 will be starting, and then minus 1 for this element, and minus 2 for this element, and then minus 3 for this element, minus 4 for this element, and then minus 5 for this element. So from minus 1, it will go on till the end. So first we have stu info minus 3, 1, right? So first we need to select the element inside of the bigger list, that is minus 3 index element. So if you see, this element is the minus 3 element, that is 13, 19 and 15. So inside of this, so we have the second bracket, that is selecting the element inside of this inner list. So 1. First, let's keep the positive indexes. So 0, 1, 2. So 1, we want 1. So what is the 1 index position element? That is 19. So stu info of minus 3 and 1 will produce us 19. So that is the element it will produce. So let's run this. And I'm printing the element. So that is why I'll be getting 19. And then moving on, I can also use negative indexes, right? So if I try minus 1, let me clear this. So first we have minus 3. So minus 3 means minus 1, minus 2 and minus 3. So this is the element. So 13 comma 19 comma 15. And inside of that I want to access minus 3. So negative indexing starts from right to left. So that will move from minus 1, minus 2, minus 3. So what is minus 3? 13 is minus 3. So when I print stu info of minus 3 and minus 3, I'll be getting the element 13. So let me run that. So if you see here, stu info of minus 3 is to minus 3 is 13. So in that way, you can access elements inside of inner list or nested list inside of a bigger list. You can also perform indexing, slicing with positive indexes or negative indexes also. And then moving on, we can also access elements using slicings also. So here what happens is our list is the same list. If you see here, this is the list. So 0, 1, 2, 3, 4. So this is the list, right? So we have stu info of 3. First 3 means this is the inner list. So it will select these 76, 56 and 67. So this inner list is selected using the first 3. And then we have the second brackets. So this is used to select the elements inside of the inner list, right? So we have colon, colon. So basically here the syntax is beginning is to ending index. Beginning index is to ending index is to step. So step is nothing but it's like an interval which we are skipping. Okay. So by default, If I don't give any values here, if I give values here, it will consider that values. But if I don't give any values here by default, so here default values are taken. So by default, the beginning index here is 0. That is, it will start with 0, right? Any list will start with 0. So beginning index is 0 and ending index, it will be taken as the length of the list. So the element here at the third position is this. So the length of this list is 1, 2, 3. 3 elements I have. So and length will be the ending index, which is 3 here. And step is by default 1. Okay, if I don't give anything, it will be considered as 1. So what is it here? First, the beginning index and ending index will check. So here, if step value is positive, the values will be taken from left to right. But if you have negative value like -1, it will be taking elements from right to left. Okay. So as we have a positive step value here, we'll be taking the elements from left to right. So positive step value. So put that aside for now. So our range is beginning index is to ending index, that is 0 is to 3. 0 is to 3 means it will consider elements from 0 to 3 minus 1. That is ending index minus 1. So 0 to 2. So that is 0, 1 and 2. So it will consider all the elements here. So 0, 1, 2 is our range of elements. As the step value is 1. So first it will consider the 76. Okay. As it is the first element, it will consider 76. So from 76, the first element is here, 56. It will move here. So it will point to 56 and it will print 56. And from 56, it will check the first element. So that is here. It will point to 67. So in this way, the elements 76, 56 and 67 are printed. So for suppose we take step value, let's say 2. So 2 if we take, first your pointing will start from first element. So it will point to 76. From 76 it will check the step value is 2, right? So due to 2 it will check the second element from the pointing element. So first it will point at the starting value, that is 76. So from here it will check the second element, that is 1, 2. So this is 1, 2. This is the first element after 76 and 67 is the second element. So from here it will jump like 1, 2 and it will skip 56 and it will print 67 if we have the step value of 2. So first let's check with the default values which we did before, that is 0 is to 3 is to 1. Okay, or basically we can write it like this. So this is only for this list. Okay, it's not for all lists. So first let me print this. Okay, so basically it will give, when the step value is nothing, it will consider as 1, I said, right? So it will give me all the values from 0 to 1, like 0 to till the end. If my step value, so let's say print of stu info of 3. So I want this list 3. And then inside of that, I want beginning index and ending index by default and step value 2. So what I'll be getting? So as you can see, 76 and 67 it printed. So just now I explained it, right? Step value when it is 2, it will check first, it will point to the first element and then from there it will move to 1, 2. It will point to the next element and this 56 is skipped. So that is why you will get 76, 67. Without step value also you can access elements, all the elements in this particular list. Okay, that is how is print of, you can give to info, that is the variable name I gave, and inside of that I want to get all elements to be printed from this position. So this position is 0, 1, 2, 3, 4. So that is the element at the position 3. So I'll be giving first, in first bracket I'll give 3 and second bracket I'll just give colon. So this will also print me all the elements in my list. So here we just didn't give the syntax of step. Okay, so when there is only single colon, So that is beginning is to ending index. So I just didn't give you the step value. By default, step is 1. So in this way, if I give just this, it will print all elements. Or if I will give both columns also, it will print me all elements. Here syntax working is here this, and here the syntax working is beginning is to ending is to step. So both are almost similar. When I don't give the values, by default it will take the values. So beginning index will be 0 and ending index will be the length of the list. And if I give the step also as blank, step will be 1 by default. So if you want to access all elements in a particular list, you can use either just single colon or 2 colons. So that will give you all elements in a particular list. How you can use this? List of, so the list name is to this, or list is to the 2 columns. And that is how it works. So here we have the step value of -1, right? So first it will take the third index element, that is, so first it will take this element 76, 56, 67. So the first bracket, it is 3, right? So that is why it will take the element at the position 3. And then it will perform this second. So we are selecting elements inside of this list. So how we are selecting? Colon, colon, -1. So here beginning index is nothing. They didn't give anything. So beginning index will be considered as 0. And ending index will be considered as length. Length is what? 1, 2, 3. 3 elements you have, no? So ending index, that is length is 3 here. And step value is -1. Okay. So first, as the step value is -1, the elements will be taken in the order of right to left, that is back to front. If it is positive, we'll be taking from left to right, right? So if it is negative, we'll be taking from right to left. So that is how we'll take first. And then, just a second. So it will take elements from 0 to 3. Like this is the ending index, right? So it will take from 0 to 3 minus 1. So 0 to 2. So when we give a range, it will take elements from 0, that is the beginning index, to ending index -1. Beginning to end index -1. So that is why 0 to 2. That is 0, 1, 2. Okay. So if we now perform it, so this 0, 1, 2, right? So this is my range of elements. And I'm taking elements from right to left as it is a step value of -1. So first, as we are coming from back, first it will take 67. So it will print 67 and then it will move to the front. It will take 56 and print it. And then it will move to the front, that is 76. So when you want the reversal of some list of elements, you can use this. That is, you can use colon, colon, -1. So if you want to reverse a list of elements or a list of a string or anything. So if you want to reverse elements, you can use this. So it will print me 67, 56 and 76. So if you see here, I got the reverse of this list. That is 67, 56 and 76. Okay. So now I can also do, so this is my list now, right? I can also add elements into these inner lists, and also I can insert elements at some specific locations. I can also sort them, and also into ascending and descending order also I can sort them. Okay. So here what we are doing is append to info of 2. So first 2 means what? Here 2 indexes this element. So first this element is considered, that is 13, 19 and 15. And for that append 14. So what append does is it will add single element at the ending of the existing elements. So it will add here. So what happens is 14 will be added here and this will be our new list. Okay. So let me print that first. So my stu info is this. Now I am trying to append 14 at the inner list, which is at the position of index 2. So if I perform that and print it, so as you can see, in this list, 14 is added. So it is appended at the end. Now, if I try to sort, so this same inner list I am trying to sort. Sort basically, by default, it will sort into ascending order, right? So if I perform this, the elements are all sorted in ascending order. So 13, 14, 15 and 19. So if I want the descending order, what will I do? I'll be giving stu info of 2. So it will select this list. So first it will select this list at the position 2 and it will sort into reverse equals to true means descending order will be given. So it will give 19 comma 15 comma 14 comma 13. So it will sort the element this inner list in this way. So let me perform that. So if you see here, so as you can see, it is sorted in descending order. First, I've sorted it in ascending order and in the same way I can sort it in descending order also. If you want in-depth explanation, you can go to the yesterday's video in the Python for AI 2026 playlist. And also I can try inserting elements inside of some inner list. So here if you see this code part, so I'm accessing the element at the position -2. So negative indexing will start from -1 from right to left. So -1, -2, -3, -4 and -5. So here I want to insert into -2. -2 means this list, that is 76, 56, 67. Okay. Now I want to insert into this index. So insert function works how is the syntax is index, at which index I want to insert, and the element, which element I want to insert. So index is 1, right? So if you see the normal indexes first is here 0, 1, 2. So one index at the one index position I want to insert. So that is here. Element I want to insert is 68. So if I do that, so I have inserted the element there and now I am printing it. So if you see here, the elements 76, 68, 56 and 67. So the index is 0, 1, 2, 3, right? So at the index position 1, I have inserted 68 inside of this inner list. So inner list I can access by the variable name is to the index dot insert. So first it will access this and dot insert will do what? It will take 68 element and it will insert into the position 1 or the index 1. So here the index is 1, right? After 0, it is 1. So there it will be inserted. And then moving on. So we can also do the descending operation, descending order. And then we can also pop elements from your list, which consists of inner lists also. So here, this is my list. So this is my list, right? The updated list is this. So I want to pop the element at the index position 2. So that means, so the indexes, first element is 0, 1, 2, 3, 4, right? So I want to pop in element at the index 2. So stoinfo.pop of 2, that is 19, 15, 14, 13. So this list which consists of 19, 15, 14, 13 are popped at the position index 2. So if I pop that, my output will be this. So after popping this element at the position 2, which is an inner list, so this is my remaining list. 10 RS, 7, this inner list, and then OUCT. So these are my remaining elements in my list. And moving on, I can also pop using negative index also. So if you see, this is my updated list, right? So this is my updated list now. So in this negative indexing, so -1, -2. So this inner list is the -2 index element. So if I pop that, that will be removed. Pop means to remove. So if you see here, this list at the position -2. So -1, -2, that is popped. So removed. So the remaining elements are 10, RS and OUCT only. So this is a normal list, right? So now I want to insert another list inside of this list. So I'm just making inner list. I want to add inner list instead of some list, which is 10, RS, OUCT. So here if you see, stu_info, which is my variable name, that is this list. Insert a list of 12, 19, 14, 11 at the position index 1. So index 1, I want to add this list. 1 means what is the index? So R, 10, RS, OUCT. These are my elements in my list, right? So indexes are starting from 0, 1, 2. So at the position 1, index 1, my list will be added. So that is here in place of RS, that will be added and this will be moving forward. Okay. So at the position 1, after 0, the position will be 1, right? So in this position, I am adding 12, 19, 14, 11 list. So let me just do it. So here, if you see at the position 1, that is index 1, 0, 1, 2, 3. At this position, I have inserted one more list. So this is an inner list. So I'm trying to pop. So stu_info of 1. So 1 means the element. Now, just now we added, right? So that is my index 1 element. In this list, I want to pop the element at the position 2. So that is 0, 1, 2, 3, right? So basically, stu_info of 1 means it will check which element I want to access. So I want to access this element. So let me write it at the side. So this element I'm accessing. Instead of this, I want to pop element at the position or the index 2. So if I write the element 0, 1, 2, 3. So these are the indexes, right? At the position 2, I want to pop. So 14 will be popped. So now let me run this. So if you see here, at the position 1, so index 1, I popped the index 14, which is at the index position 2 inside of this inner list. I popped that. So if you see in the updated list, there is no 14 and the remaining elements are printed. So in this way, I can also pop elements from inside of inner list. Now I'm trying to insert one more element, that is a list at the position 3. So 3 means here 0, 1, 2, 3, right? So at this position, I want to insert our list 56, 78, 66, 77. So basically 3 means after 2 it will be. So here our list will be added. So just let me run it. So as you can see here, the element or the list 56, 78, 66, 71 is added at the position or index 3. So this element has position 0, this is at 1, this is at 2, this is at 3 and this is at 4, right? So at this position, my list is added. So this is an inner list. So we have two inner lists in this main list for now. And then moving on, we can also append another list. So using dot append function, I am trying to append a list which consists of strings apple, kiwi, raspberry, banana. So what append does is it will add elements at the end of existing elements in your list. So at the end it will add. So if I try to perform that. So as you can see here, the new list apple, kiwi, raspberry, banana is added at the end of your elements of your list. So that is how I can do it. But I cannot like append this because the difference here is, if you see, there is square brackets here, right? So this is a single element, a list. So we are appending a list, which is one only. So one argument I'm giving. But if you see here, there is no square brackets, right? So you're appending apple, comma, kiwi, comma, raspberry, comma, banana. So this is not possible because your append will only take single argument or like single value. Only one value it will take. But as I'm trying to append too many values at once, so that way it will give error. That is list.append takes only one argument, but four given. So four are given. So it is telling four are given, but only one it will take. But here, if you see, I gave a list of elements. So inside of this one list, I am giving all these string values. So this full list is considered as one value. So that is why it is appended here into our list. And then here, there is something you need to know. Yesterday we learned about extend also, right? So what your append does is it will add only single element at the end. So how it will add is, let's say I have a list 1 comma 2. Okay, I'm trying to append a list which consists of 3 comma 4. So it will add this list directly as a single element. So if I print, so the 3 comma 4 list is added inside of my list 1. So this is a single element, considered as a single element. In the same way, if I try to add some string value, okay, dot append string of AB I am adding. So if I print it, so I added a string value AB inside of my list 2. So that is added like a single element here. But when you try to use extend, what happens is does not add any list as one object. It will not add your list like 3 comma 4 if I do. If you see here, I'm trying to add using the extend function 3 comma 4. What it will does is it will not add this single list as it is. It will take each element inside of 3 comma 4 and it will add them individually. So if you use extend function, what it will do is it will take elements individually and it will add it. First it will add 3, then 4. So first my list 3 has elements 1 comma 2. So using extend, I'm trying to add 3 comma 4. So if you see here, list 3 dot extend 3 comma 4. And if I print it, so as you see, 3 comma 4 are added as individual elements. But if you do it in append, it is added as a single list. But if you use extend, it is added as single individual elements 3 comma 4. Same way, if I try to add some string element. So there is my list 4 which has 1 comma 2. Even if I give the string of A comma B and I use extend, what happens is they'll be added as A and B individually. So if you see here 1 comma 2 comma A comma B. It is not added as AB. It is added as A comma B. So as individual elements. So that is the main difference between append and extend. What append does is it will add as a single element in your list. But extend, it will take each element inside of your list and it will add them individually. Even if it is a string, it will add them individually. So that is the difference. Now we're gonna know about copy processes. So there are three type of copy processes. So copy is nothing but it is a process of creating another variable or object from the existing object. So copy means you will be doing copy paste, right? Control C. So what it does is it will take one file and it will copy the same file into one more file. So if you do copy or Control C, it will just copy all the elements or all the content of your one file into another file. So in Python, we have three type of copy processes. They are reference copy, shallow copy, deep copy. So reference copy is nothing but It is a copy where we use the assignment operator. Assignment operator is nothing but the equal to. So if we have a list 1, so it has, let's say, 10 comma 20. So these are first my list. And then I'm trying to copy this list 1 elements into list 2. So what should I do is I can just give L2 or the list 2 equals to list 1. So my list 1 elements are copied into L2. Okay. So if you try to print, let's say I want to print L2. So this will print me the output, that is 10 comma 20. Okay. So here using the reference copy, no new object will be created. Just the same list is copied into this, and L1 will refer to some memory address. Okay. This list object is saved into some memory address in your computer memory, right? So let's say it is saved into memory A. It has some combination of numbers, right? Let's say it is saved into memory A. So when you use this reference copy, what happens is the elements in L2 will be copied into, sorry, elements in L1 are copied into L2, and L2 will be created as 10 comma 20. But your L2 object also will be pointing to the same memory location, that is memory A. So what happens is both L1 and L2 will point to the same memory location, that is memory A. So they are just two names for the same object. Like for the same object, this object 10 comma 20, it is a list object, right? So this list value is saved into some object. That object is saved, like it references to some memory location. Let's say A. So what happens is first your L1 variable, it is a variable, right? So this will point to this memory location which consists of 10 comma 20. So when you use reference operator, sorry, reference copy, and you do L2 equals to L1, so your L2 will also just point to the same location where you have 10 comma 20, that is memory A only. So if you check the memory of L1 and L2, the same memory will be given. If you modify L2, that will be reflected in L1. And if you modify L1, that will be reflected in L2. Because in the same memory location, you are pointing these variables, right? L2 and L1. So if I add 30 here, let's say. So L2 also will be 10, 20, 30, and L1 also will be 10, 20, 30 only, right? As it is pointing to same location. So this is how reference copy will work. So this is the fastest method, but it will change both, like both the copies it will affect. So let's look at code and then you will understand it in a better way. Okay, first we have a reference copy. Here if you see L1. In L1, we have the elements 10, rosum and 1 comma 2. So this is some inner list. We have one more inner list inside of the bigger list. Okay. First, let me print this. So my L1 list is saved at the position 2191120934656. Don't remember all these numbers. Just let's look at the last four numbers. Okay. 4656. Let's say L1 is pointing to the memory location. So in this memory location, we have this list value, that is 10, rosum and 1 comma 2. So in this is stored at the memory location, let's say 4656, some value 4656. Okay, now I'm performing reference copy, that is L2 equals to L1. So what happens? L2 elements are copied into, sorry, L1 elements are copied into L2 variable. So that is a list. So what happens here is I'll perform this, and if I print L2, so the same elements as in L1 are copied into L2, and your L2 will also point to the same memory location of L1. So if you see here the same 4656 value. So what happens here is first your L1 is a variable. So this is a list object, and this list object address is 4656, let's say. So after, first it will point this way. Your variable will point to your memory location, which consists of this list value. Let me write it a better way. So it consists of the list 10 ROSM and one more inner list, that is 1 comma 2. Okay. So this list value is saved in an object which consists of a memory location 4656. Okay. First is this. Then when I do L2 equals to L1. L2 equals to L1, right? So L1 elements are copied into L2. That is, L2 will have 10 ROSM 1 comma 2 only. So our L2 also will point to the same location. So that is why L2's address also will be 4656 only. L1 address is also 4656, L2 address also 4656. So that is why if you see the same numbers combination is for L1 address, ID of L1 also same address, ID of L2 also same address. So both of them point to same memory location when I do reference copy. So that is why. So outer objects. So ID of L1. So you can use ID of function to get the memory location of any object in your computer space. So ID of L1 comma ID of L2. So I'm printing it. So when I do this, the address of L1 and L2 are both same. So this first number is L1 address, L2 address. As they're pointing to the same memory location, the address also will be same. Okay. Now, if I try to get the address of just this inner list, let's say. So the inner list also, the addresses will be same. So if you see here, these are the addresses of the 1 comma 2, which is in L1. And this is the address of the 1 comma 2 inner list, which is in L2. So if you see the addresses, let's take the last 2144. So this is also 2144. So both the outer loop addresses also same for L1 and L2, and inner list addresses also are same when we do reference copy. So the whole thing will point to the same memory location. So that is why when you modify the elements, so L1 dot append Python. So what here I'm doing is I'm adding Python string to L1 here. So here it will be added Python. So let's see. First, I'll perform the append operation, that is here. And now I'll print L1 and L2. Okay. So if you see here in L1, it is appended. So it shows here also. Here also it will reflect. In L2 also it will reflect. Why? Because is both L1 and L2 are pointing to the same location object, right? So the same memory it is pointing. So when I append or add or remove elements in L1, that will be reflected in L2 also. As I'm editing the same thing here, in L2 also this will only will be reflected, and in L1 also the same thing will be reflected, and in L2 also the same thing will be reflected. So that is why when I try to edit or modify L1 with some string Python, that will be reflected in L1 and also L2, as they are pointing to the same memory address. So moving on, now I'm trying to append some value 3 in my inner list. Okay. So here now the list is this, right? So this is L2 if you see. So the values are 0, 1, 2, 3. So at the position L2 of 2, 2 means the inner list 1 comma 2. So for this I want to append a value 3. So what append does is it will add here, right, at the end of the list. So if I try to do that, now I am appending. So I'm printing L1 and L2. So if you see here, this is L1 value and this is L2 value, okay? I just appended 3 inside of the inner list of L2, right? But it shows in L1 also, the same list. So when I try to modify L2, the same change will be reflected in the L1 list also, as they are pointing to the same memory address. The object or the list object, the same it will be there in L1 and L2 also. And moving on, the second copy is called as shallow copy. So shallow copy, so in a shallow copy, what happens is I can perform shallow copy using dot copy function. So I have some L1, let's say 1, comma 2, 2, comma 3, comma 4. So I have some L1 object. Now what I'm doing is I am copying using the shallow copy operation. I'm copying L1 elements into L2. So L1 dot copy. So when I do this, the L1 elements are copied into L2. So when I print L2 here, that elements will be 1, comma 2 and 3, comma 4 only. So here, new outer object is created. That is, this new object, that is L2, is created in a different memory location than L1. If you see the L1, L1 will point to some memory location, let's say A. Okay, memory A. When I perform shallow copy using dot copy function, what happens is the elements of L1 is copied into L2. The elements will be same, but L2 will be stored or point to different memory location, that is, let's say memory B. Even if your elements are same, L1 will point to different memory location and L2 will point to different memory location. However, the inner lists are there, right, which are mutable objects. So that is 1, comma 2, 3, comma 4. Here also there is 1, comma 2, 3, comma 4. So the outer list will point to different locations, but the inner lists, which are 1, comma 2 and 3, comma 4. So these guys will still share the same memory address. So when you perform shallow copy and copy elements of one list object into another list object, the outer list will consider like it is stored in different memory locations. But the inner lists are there, right? So that will share the same memory location or the same address. So here modifying the outer structure, that is the outer list is independent. So if I add one more new list here, like 5, comma 6, if I add 5, comma 6 list into L1, it will be only reflected in L1. Like in this way, it will be reflected in L1 only, but it will not be reflected in L2. L2 will still be 1, comma 2, 3, comma 4 lists only. But if you modify the inner or the nested lists, if I add some, let's say, if I add 7 here, 3, comma 4, comma 7, so I am adding 7 in my second inner list. So this inner list added element will be reflected here because they share the same memory location, right? So if I modify the inner lists, that will be reflected in both the list. But the outer lists, if I modify the outer list, that is adding new elements, removing elements, in that way, that would be only reflected in which list I did. It's a little confusing, but we'll understand with code, don't worry. So this shallow copy is used for flat lists, as the outer list will point to different memory locations. It is safe for flat lists, but it is risky for nested structures because the inner list or the nested list will share the memory locations, right? So that is why it is a little risky. Now let's look at the code. So then here we have a list 10 comma rosum comma 1 comma 2. Okay, so that is our list L1. So this is my list L1. So if you see, let's print that. So my L1 has the elements 10 rosum and then another list 1 comma 2, which is the inner list. So this is pointing to some memory address 6352. Okay. So my L1 is pointing to an object that is a list object, that is this value only. So it will point to some list object which is stored in the memory address. Let's take the last four letters. So 6352. So this will L1 will point to memory address 6352. Now what I'm doing, I'm performing the shallow copy operation. That is L2 equals to L1 dot copy function. So this is a shallow copy. So what shallow copy does this? L2 will consist of same elements only as L1, but it is stored in a different memory location. So the same elements will be there. 10, rosum, 1, comma 2. So these elements are only copied. So this is the same elements are copied, but they are copied in new address location. So let's find that address location now. So now I'm printing L2. So if you see, just a second, guys. So yeah, 1 second. So we just printed a different one. So here L1 consists of 10 rosum and 1 comma 2. So the memory location is 7312. The actual one, okay? 7312. So L1 points to 7312 location. Now I did a shallow copy to L2. So the elements of L1 are copied into L2. That is 10 rosum 1 comma 2 only. But they are stored in different location if you see. So 5872. So the outer lists are copied into different memory locations if you see. L1 is copied into 7312, L2 is copied into 5872. So outer lists are copied into different memory locations. But so for comparing, I have compared ID of L1, comma ID of L2. So these both are the addresses of L1 and L2. L1, L2. So the address of outer lists are different. But if I try to get the inner list, so that is inner list is 1 comma 2, right? So how I'm getting it? L1 of 2. So the indexes are 0, 1, 2, right? So L1 of 2 will give me the 1 comma 2 list, and L2 of 2 will give me the same 1 comma 2 list. So that is how I'm getting the ID of. ID of means it will give the address of L1 of 2 and ID of L2 of 2. So if you see here, the inner lists are saved at the same location. So if you see 5328, 5328 only. So this is L1 of 2 and this is L2 of 2, which is 1 comma 2 in L1 and 1 comma 2 in L2. Even if your L1 points to different location, the outer list, and L2 points to different location, that is the outer list 5872. Even if the outer list will point to different memory locations, when I use a shallow copy, the nested lists, that is the inner lists, here 1 comma 2 list and 1 comma, so it is copied into L2, right? So this nested lists, what they'll do is they will still share the same memory location. So the 1 comma 2 list in L1 and 1 comma 2 list in L2, they are both pointing to same memory location, that is 5328. When I use a shallow copy, the outer lists are pointing to different memory locations, but the inner lists here, these both will point to same location, that is 5328. Let me just erase this so you'll get a better idea. So when I'm performing a shallow copy, the outer lists, that is L1 and L2, will point to different memory locations. But when I have an inner list instead of these outer lists, that lists, so 1 comma 2 in L1 and 1 comma 2 list in L2, point they both will point to same location, that is 5328. So this is how shallow copy works. So here if you see, let's do some modifications on these lists. So now I'm modifying list L1. So this is modifying the outer structure, that is the outer list I'm modifying. So outer list means L1 list I'm modifying. I'm not touching the inner list now. So I'm trying to append a Python string into L1. So if you see this 10 ROSM L1 comma 2 list and Python, that is reflected in L1. If I try to print L2 now, in L2 that won't be shown because as L1 points to different location, when I do append of Python, it will only added into this. As L2 is pointing to different location, this Python string won't be reflected here because I didn't add it here. Only here I've added it. So as they are stored in different locations, when I modify one, that is the list 1, only it will be reflected in list 1 only. And if I modify L2, it will be reflected in only L2 only. The modification in L1, that is the string append of the string Python, will only be reflected in L1. It will not be reflected in L2. You can see here there is no Python, right? So it will only show in L1. And then moving on. Now let me try modifying the inner lists. Okay, inner list means the list of 1 comma 2 and list 1 comma 2 in both L1 and L2. Okay, as you know, these inner lists are pointing to same location, that is 5328 only, no? So when I try to modify the inner list in L2, in L2 I have 1 comma 2 list. So that is 10 ROSM 1 comma 2. So this is my L2 list. Okay. What I'm doing is I'm trying to in position 2, that is 0, 1, 2. In position 2, I'm trying to append 3. So position 2, I have an inner list. Inner list, I'm trying to append 3. So 3 will be added here. Okay. 3 is being added in the inner list 1 comma 2. So when I add that, what it will become? 1 comma 2 comma 3, right? So as the inner list in L1 and L2 share the same memory location, this modification 1 comma 2 comma 3 will be reflected in both L1 and L2 because these inner list will share same memory location. So let me print that, okay? Now I am trying to append 3 into my inner list 1 comma 2. So when I print both L1 and L2, so as you can see, inner list modification will be reflected in both the copies. So both the lists it will be reflected. But when I try to modify the outer list, that is the outer structure, that won't be reflected. As the outer lists are stored in different locations, when I modify the outer list or the outer structure, it will only be reflected in one list. In which list I changed, in that list only it will be reflected. As you can see, the Python string, I have appended that into L1 only. So in L1 only I can see that. But when I try to modify the inner list, that is 1 comma 2. Initially it is 1 comma 2, right? So you can see here 1 comma 2 initially. So when I try to modify this inner lists, in both it will be reflected. In both the list it will be reflected because they both are stored in same memory location 5328 only. So that is why when I added 3 in only the inner list of L2, in only this L2 list I've added, but you can see it is reflected in both L1 and L2 inner lists. That is because they share the same location or memory address. So that is how shallow copy works. So now moving on to deep copy. So deep copy. So how you can use deep copy is there is a module called as copy module. You learn about modules, just remember how you can use or create a deep copy right now. Modules, packages from about that you'll learn later. So just remember this. Import. Import means to our local environment, we are importing a module copy. So in that copy module, I have a function called as deep copy. So how I can use it is first we'll write the module name dot function. So in that way, I can use any function in any module. So this is how we'll write it. So as the module is copy, I'll write copy dot the function is deep copy directly deep copy parenthesis. So in this way, I can perform deep copy. So deep copy is nothing but it will create completely independent clone. So that means when I do, we have a L1 list. Okay. I want to deep copy this and I want to create L2. So when I perform deep copy, these both are stored in different memory locations. So L1 will be stored in A memory location and L2 will be stored in B memory location. Even if it has inner lists, in outer list, both the outer list are stored in different locations. Like the L1 and L2 are stored in different locations. Even the inner lists are also stored in different locations. So this inner list is stored in D and this list is stored in C, let's say. So the inner lists are also stored in different locations. So they don't share any addresses. So they are completely different objects and independent clones. So L1 is independent of L2. So completely newer outer objects are created and completely new inner objects are also created. The elements are copied, but they are stored entirely in different memory locations when you do deep copy. Okay. So if you see memory addresses of all levels are different. Outer levels, that is outer list or inner list, all are different. Any modification does not affect any original. So if you modify the list 2, let's say, if I modify list 2, that won't be reflected in list 1. Even if I modify the inner list of list 2, that won't be reflected in inner list of list 1. So that is how they are completely independent, okay? So this is safest, but it is slow. So when you want to work with nested structures, you can use deep copies. So here, first, I'll import copy, which is the module. So this is a copy module. And here I have a list 10 ROSM 1, comma 2, which is a list. Okay. We have an int value, string value, and one more list value. So here that value is L1. And if you see, L1 is stored in location, let's say 2144. Okay. So let's write that. Okay. L1 list is stored in location 2144. And now I'm performing deep copy. Deep copy of L1. So L1 elements are copied into L2. And L2 is created in a fully new object. It is created as a fully new object. So if you see here, L2 consists of the same elements as L1, but it is stored in entirely different memory address. So now L2 will point to different memory location, that is 7, 3, 1 and 2. Okay. So L1, the outer list, is stored in 2144 different location. L2 is consists of L1 elements, but it is stored in different location, that is 7312. So when I want to compare my outer list addresses, they are completely different. Starting values a little will be same, but if you check the last four digits, this is stored in 2144 and this is stored, L1 is stored in 2144 and L2 is stored in 7312. But here in deep copy, as I've said, inner list also will be stored in different locations, right? So here L1 of 2 means, so this is L1, right? 0, 1, 2. L1 of 2 means this inner list. L2 of 2 means 0, 1, 2. L2 of 2 means it is this list. So these both lists, inner lists, will also consist of different locations. So these are also stored in different locations. They don't share any memory address. So if you see the 1 comma 2, this is the 1 comma 2 in L1, okay? And this is the address of 1 comma 2 in L2. So if you see at the addresses 4928, 8208. So the inner lists are also stored in different memory locations. The outer lists are also stored in different locations and inner lists are also stored in different locations. If you see in shallow copy, only the outer lists are stored in different locations, but the inner lists will consist of same memory address, right? It will point to same memory address. But here, if you see, it is entirely different. The outer lists are also stored in different locations and inner lists are also stored in different locations. So that is how you will do deep copy. So if you try to modify the outer list now, so I'm trying to modify L1 which is stored in 2144. I'm trying to add Python string into L1, okay? So if I try to add Python into L1, so what will happen is, this Python string will be reflected in L1, but it will not reflect in L2 as they have different locations, that is 2144 and 7312. So this is stored in 2144, which is L1, and 7312 location, it has L2 object. So this is that. So when I try to modify L1, it will be reflected only in L1. It will not reflect in L2. And if I try to modify the inner list also, so if you see the index 2 means 0, 1, 2 and 0, 1, 2 both. So here I'm trying to modify L2 of 2. So that is here, this is 0, 1, 2. So I'm trying to modify the inner list here and I'm trying to append 3 into that. So here I'm appending 3. After 2 I'll get 3. Now let's do that. So I appended 3 into the inner list 1 comma 2, which is an L2 list object. So if I print L1 and L2, as you can see here, this 3, the appended 3 is only reflected in L2 list object. So in this only we have 1 comma 2 comma 3. It is not reflected in L1 because the inner list also are stored in different memory locations. When I modify the inner list of L2, that is not reflected in inner list of L1. So that is an independent and entirely different lists here. Using deep copy, we can do that. So here, so let's say I have reference copy and I have shallow copy and I have deep copy. Okay. So in reference copy, new object, new object is not created. Just the same object reference will have, right? That memory allocation. The L1 and L2 will point to the same object which is stored in that location. So new object is not created by the reference copy. And using the shallow copy, only the outer object is only created, like at a different locations, outer object is created. In deep copy, both outer and inner lists are at different locations. So entirely new object is created. When it comes to nested objects, in reference copy, the nested objects will share same location. And in shallow copy, the nested objects, that is nested lists also will share same location, right? Here, all the outer and inner list will share same location. In this, the outer lists will have different memory addresses. Outer list will have different memory addresses. But inner list have shared memory address. Okay, that is the shallow copy. In reference copy, both outer and inner also, it will share the same location like L1. The outer list L1, L2 have same location and the inner lists of L1 and inner lists of L2 also will share the location. When it comes to shallow copy, outer lists will have different addresses, inner lists will have shared address. But when it comes to deep copy, both outer lists and inner lists, they'll have entirely different memory addresses. So that is the difference. So if you modify the list here, so if you modify L2, that will be reflected in L1. Using the reference copy if you do. If you modify L2, it will be reflected in L1. If you modify L1, it will be reflected in L2. Even if you modify the inner lists also, if you modify one, it will be reflected in the other thing. But in shallow copies, if you modify the outer lists, as they have different memory locations, that won't be reflected in the other one. So if you modify L1 outer list, like the outer structure, if you modify it using some append or anything, if you modify that, as the outer lists will have different memory locations, if you modify L1, that won't be reflected in L2. If you modify L2, that won't be reflected in L1. But as the inner lists will share the location, if you modify the inner list of L1, that will be reflected in L2 inner list. And if I modify the inner list of L2, that same modification will be reflected here as they consist of same location. And in deep copy, as it has entirely different memory locations, the outer structure or the inner lists, they'll contain different locations. They'll point to different locations, right? So when I modify L1, that won't be reflected in L2. When I modify L2, that won't be reflected in L1 also. Even if I modify the inner list also, if I modify inner list of L1, that won't be reflected in L2. And if I modify inner list of L2, that won't be reflected in L1 because the outer structure and inner lists will consist of different locations entirely. So when to use what? So you can use the reference copy or the assignment operator when you want to have aliases. If you want aliases, you can use reference copy. Okay, if you want flat lists, you can use shallow copy. Flat list means the outer lists. So they'll consist of different locations, right? So that is why you can use shallow copy in this case. So when you want to work with nested lists, then you can use deep copy. So this is the cases you can use. Now let's know about tuple. It will just take some time. So please be patient. We'll complete it soon. So tuple. Tuple is very similar to list, but the major difference is lists are stored in square brackets where your tuple is stored in parentheses. So tuple is a predefined class and is treated as list category data type. So tuple also same as list, it will store multiple values either of the same data type, that is all int values or all string values, or it can also consist of different data types, that is int, string, float at once. It will consist of different data types, or both cases also it will have with unique and duplicate elements. You can also have unique elements and you can also have duplicate elements in your tuple. And the elements of tuple must be written within parentheses. So these are the parentheses. So this is called as parentheses. And the elements are separated by commas. So when you are writing elements, you need to separate them with commas. And the objects in insert sorry the objects in tuple will maintain the insertion order. That is, in which order you will insert the data, in the same order the elements will be displayed also. So you should think of a tuple like a university roll number, let's say. So the same roll number will be assigned for the whole 4 years, right? So it is permanent. So that is why your tuple is immutable. So you cannot change the tuple. So that's like a permanent Aadhaar number. Like you cannot change it once it's created. So that is how tuple works. And that is why it is immutable. And tuple will support the operations indexing and slicing. Indexing means obtaining a single element from the tuple, and slicing means obtaining the group of elements from the tuple. So this will support both the operations. And you can convert any other type of value like list or other values into tuple using the tuple function. And there are two types of tuples, that is empty tuple. You can have or create empty tuple using this parenthesis, and this empty tuple doesn't contain any elements and the length is 0. And when it comes to non-empty tuple, it will contain elements and length will be greater than 0 as it has elements. So length will be greater than 0. So the functionality of tuple is exactly same as list, but list is mutable and tuple is immutable. Now let's look at the coding of tuple. So here, so first I can create tuple using a parenthesis, right? But what you should remember is, if I just create a parenthesis and put some element inside of it, this is not considered as a tuple. So it is considered as some int element only. But if you want to mention it is a tuple, you should keep a single comma. If your tuple consists of just one element, you should surely keep a comma here. So the comma defines your tuple, not the parenthesis. The comma will define this thing as a tuple. So if you see, if I run here, 10 comma I gave. So tuple 2, the type of tuple 2 is, so it's a tuple. So now that is considered as a tuple because of your comma, not the parenthesis, okay? So now we have a non-empty tuple which consists of the values 10, 20, 30, 40, 50, 60. So these are int values which is of same data type and they have unique values. So different values, right? We don't have any duplicates here. So when I try to print that, so this T1 tuple, so that consists of these values and it is classified as tuple data type. And the elements, the number of elements is the length of your tuple. So len of will give you the length of the object here. So the tuple object. So you have 1, 2, 3, 4, 5, 6, right? So 6 elements, that is why length is equal to 6. And then moving on, we have tuple which has different data type elements. So we have int element, string element, float, boolean, and also one more string, right? So in this way also you can create a tuple. So it consists of the elements and it is a class tuple. That is, it is of tuple data type. The length is 5 because it has 5 elements. 1, 2, 3, 4, 5, right? So that is why length is equal to 5. So if you see here, this is an empty tuple. So I can create an empty tuple using just parenthesis. But when I have a single element, for sure, I should keep a comma after that. In that case only, it will be considered as tuple. If it is empty tuple, I can just give parenthesis. So length of that, as it doesn't have any elements, it is given as 0. And using tuple function also, that is tuple parenthesis, I can create an empty tuple. So my T4 here is an empty tuple. It doesn't contain any element. That is why the length of T4 is equals to 0. So here I have a tuple which consists of duplicates. So I have 4 tens and 2 20s. So it consists of duplicate elements also. And that is of the, it consists T5 tuple consists of these elements and the class or the data type is tuple. I can also give tuple elements in this way. So without the parentheses, just I'll give commas and the elements. And in this way also, I can create a tuple. So this is the tuple value of T6 and it is of data type tuple. Okay. Here I have one more value where I have different type of elements, that is data type elements. So I can perform indexing. Indexing means obtaining single value, right? So now this element I am trying to get. So T of 0, T2 of 0. So this is T2, right? So this is my T2 element. And T2 of 0 means it will give this element, that is 10. So this is indexing. In the same way, I can get any other element here using 1, 2, 3, 4. So let's do that. Print of T2, which is our variable name, tuple name. And the index I want is, let's say 3. And also I can perform negative indexing also. So T2 of, let's say minus 2. Okay, minus 2. So here if you see, here the negative indexing starts from right to left, right? So from minus 1, it will start and then minus 2. So as minus 2 is true here, that is what the value is printed. T2 of minus 2 is this element which is true. And then moving on, I can also perform slicing. So slicing, what that does, the beginning index is 0 and ending index is 5. So it will take elements from 0 to 5 minus 1, that is 4. So it will give all the elements. So 0 is to 4 slice, 0 is to 5 slicing gives all my elements. If I do 0 is to 3, it will give the values from 0 to 2 only because 3 minus 1, 2. So 0 to end index minus 1, that is 2. Only these 3 elements will be printed. If you look here, 10, RAM, 34.56. Only T's will be printed. So this way I can perform indexing and slicing. And let's try assigning some value at the position 0. So in place of 10, I want to replace 10 with 100, let's say. So that is not possible because tuple is an immutable object, right? So you cannot modify it. So that is why we got a error, that is type error. Tuple object does not support item assignment. So using the tuple function, we can create or we can convert any other data type into tuple, right? So that is why first I created a list here, which consists of 10 RAM 34.56. This is a list L1. So initially it is a class list. So the data type is list. L1 is list. So what I'm doing here is T11. I'm creating a new tuple, that is T1, and I'm assigning it the value of tuple of L1. So tuple of L1 means L1 list is converted into tuple using this tuple function, and that is assigned to this T1 value. So that is what happening here. So if you see here, this list 10 RAM 34.56, which is in square brackets before, which is a list. Now using this tuple function, it is converted into tuple. So using parenthesis, it is represented and the class is tuple, that is the data type. So this is how it works. And then moving on, we have some important topic here. Everyone please listen. So I am creating a list T1 which consists of 10 string gram, and it consists of one more tuple. So this is an inner tuple, and it also consists of a list and then string, right? So these are the elements in my T1 tuple. So this tuple consists of all kinds of all data types elements. So let me just access these elements. So T1 of 3 means here if you see, this is the value 0, index 1, 2, 3, 4. So I am trying to access the element at the position 3. So 3 is the list here, right? So I have a list instead of this tuple. So that I have accessed, right? Now, type of the first object, 10. What is the type? Int type, right? And T1 of 1. So the type here print of, so I'm printing what? Inside of this parenthesis, I'm printing this. So type of function will give you the data type of the value you have given in this parenthesis. So basically, it is printing the data type of T1 of 1. So T1 first we'll start with the inner parenthesis, that is T1. T1 means our variable. So the index is 1. 1 means RAM string. So the type of RAM string is given by this type function, and that is printed using print. Okay. So it is printing the type, data type of the value at the position index 1. So that is string. So as your RAM is string, right? So that is the data type printed. So here we are printing the data type of T1 of 2. T1 of 2 is here. This is the value of T1 of 2. That is 14, 13, 17, which is a tuple, right? So this is a tuple inside of the bigger tuple. So this is the inner tuple, okay? And at the position 3, we have a list. So that is 56, 67, 34. So this is a list. And one more we have string. So here the T1, which is the outer tuple, that is tuple only. Inside of that we have one integer data type value, string data type value, a tuple data type value, and one more list data type value. But still the outer value is still a tuple. Inside of this we have different data type values. So what happens here is, when by default your tuple is an immutable object, right? You cannot modify it. By default, it is an immutable object. Here, immutable means you cannot modify the outer structure of your tuple. That is, you cannot add new elements and you cannot assign one more, like you cannot replace this element with new element, or you cannot replace element with new element. So that is how it is immutable, a tuple. But if your tuple value consists of a data type which is mutable, like list here. So list is basically mutable, right? But tuple is not mutable. So tuple is immutable in the case of the outer structure. You cannot change the outer structure. But if your tuple, which is an immutable data type, if it consists of a mutable data type, that is list, you can change the value of or the elements inside of your mutable data type, which is a list here. You can change. In place of 56, I can keep 100. In place of 34, I can keep 1000. But I cannot change in place of this list. I cannot keep some one more, let's say string or ABC. So what happens is I cannot change the elements of the outer tuple. But if my tuple consists of a mutable object, which is like a list here, I can change the elements of that mutable element. So to clearly know what I'm doing here, first let's understand this. I'm trying to modify the list object. So here 3 means 0, 1, 2, 3. So the first bracket will give us the element, like the inner element, right? So in these elements, individual elements, I am trying to access the index 3, that is this list. So inside of this list, I want the value at the position 0. So here it is 0, 1, 2. So in this inner list, as this is a list and it is mutable, right? Lists are basically mutable. So if I try to give at the position 0, in place of 56, I want to keep 100. So as this is a list which is mutable, this will work. Okay. So basically, if you see here, in place of 56, 100 is replaced. So here what happened is, since this list value is mutable, the 56 is replaced with 100 and you will not get any kind of error. But if you see here, we have at the position 2, that is 0, 1, 2, right? So this is the position 2. So the first bracket will select the element inside of the bigger tuple. So this is the position 2. And inside of this, I'm trying to access the value at the position 0, right? So inside of this tuple, I'm trying to access the value 0. So the indexing will be 0, 1 and 2, right? So I want to access this element 14 and I want to replace that 14 with 100. But this tuple, instead of the bigger tuple, we have smaller tuple 14, 13, 17 and I want to replace 14 with 100, right? But my tuple value or the tuple data type is immutable, right? So that is why tuple object does not support item assignment. So we'll get a type error, as I'm trying to change the object stored at index 2, that is a tuple. Inside of that, we have value 14. So as this is an immutable data type, which is tuple, I cannot change that. I cannot change the internal content of it also. So here I cannot change the internal content of this tuple value. Here, if you see, I'm trying to replace the value at the position 0. So 0 means 10, right? So T1 of 0 means 10. So in place of 10, I'm trying to give 200 value. So if I try to do this, still I'll get the type error. Tuple object does not support item assignment. So what's happening here is, tuple object is immutable. So immutable means once objects are created, you cannot replace this 10 with one more value, or you cannot replace these individual values with one more value, or you cannot like add elements, or you cannot remove elements, or you cannot replace these individual elements in your tuple object. So that is how it is immutable. You cannot change the outer structure of it. But if your tuple, which is an immutable data type, if it consists of mutable data type, like it consists of a list here, right? And list is mutable. So you can change or replace or add or remove elements, the internal content of this mutable data type list. You can change that. You can replace elements, you can add elements into it in this list, specifically in this list. In the inner tuple also you cannot change or replace, right? Because that is the immutable data type tuple. So that is why you cannot change the internal content of it. As this value is a list which is a mutable data type, you can change the internal content of it, or replace, or you can do it anything. So lists are slightly slower and tuple are faster. And lists are immutable and tuple are immutable. Lists are used with square brackets and tuple are used with parentheses. So these are represented using parentheses, okay? So list is used for dynamic data. So it is mutable, right? So you can use it for dynamic data when you want to add, remove, replace, etc. But tuple objects are immutable, so you cannot change the outer structure. So it is used for fixed data. You cannot add or replace or remove any content from it. So that is how tuple works. So inside of tuple, you can also perform some operations like count. You can count the values here. So my tuple consists of 10, 20, 10, 30. So T of, basically you need to have your variable name dot. So count, what count does is it will count your number of occurrences of some value. So the value I want is 10. So the value, how many times 10 occurred in my tuple I want, means I can use the count function. So in this way also I can print it. So I got 2. So this is the input and this is the output. I can also use print of this value. So directly it will print me 2. And also I want to get the index of a value 20. So here index is 0, 1, right? So 20 is at the position index 1. So if I want an index, I can just do variable name dot index function. So index will give me the index of value I need. So instead of this, I need to give the value, that is 20, or let's say 30 here. I will print it. So 30 is at the position index 3. 0, 1, 2, 3. So that is how it works. So today we've learned about inner lists, and we also learned about copy processes, and we also learned about tuple object. So we have, till now we have completed the list category data types. In that we have completed list, inner lists, and types of copy processes, and also tuple objects. So tomorrow we'll get to know about the set category data types. So set category data type consists of the set and frozen set. So tomorrow we'll learn that, guys. So that's it for today. If you have any kind of questions, please put it in the chat box. And as some of you asked me about practice questions, I've collected some questions. You can screenshot this and you can try it yourself. And if you have any more questions, please put it in the chat box. And tomorrow we are going to learn about set category data type. So please attend it. So that's it for today. Thank you, guys. Everyone, the feedback form is shared in the chat box, so please fill it. If you like our videos, please subscribe to our channel and like the videos and hit this like button. And you can also find all these live videos in our playlist Python for AI 2026. You can rewatch them and revise the topics using that. So you'll get a in-depth information. So as some students wanted a slow explanation, I've been explaining it a little slow. But we'll cover all the topics in depth, so don't worry about that. We'll be covering all topics. So before leaving, please fill the feedback form so you'll get your attendance, and you can leave after filling the feedback form. After the class, feedback form won't be shared. So we'll wait for 5 minutes. Please fill the feedback form and then you can leave the class. Thank you.